Hello guys, welcome back. This is the video number 3 of this beautiful machine Pioneer SA 9100 for restoration. On this video we'll discuss about the power supply A circuit assembly. So it's the first power supply after the main power transformer. So we'll discuss about that board. I will show you exactly the part list, I will show you the electrical diagram, I will show you exactly which part you have to do, and I will show you the full maintenance of that board, cleaning, and what you have to measure and what you have to check. After you finish with that board, you will go on the main power transformer, we will take out the nuts and we will leave the transformer. Why? Because you have to clean around it, because it's a lot of dust there. When you will finish with the transformer, we will go on the sides on the power amplification boards. Why? Because we have also to make maintenance there, and I will show you what previous technician he did. I will show you my way how to fix everything what is there. I will show you the parts according with the electrical diagram, block diagram, and also the part list for that. So stay tuned, because you'll have all of them there, and you'll see all the parts which I will replace. When you'll finish on the sides with these power amplification boards, we'll come back on the main power capacitors, we'll install back, and you will see exactly what you have to do for have your machine like this one. So stay tuned, because I will play the rest of the video. On this video we'll discuss about the cleaning of this part here, part which belongs to left and right power amplifiers board and heatsinks. We'll slack also the main power transformer, and we'll have here this power supply board. We have to lift all of them to have access to the chassis. We'll clean the chassis, and after that we'll start to put boards one by one back. After we'll check all the parts according with the diagram. About the diagram, like you know already, I have printed this circuit connection diagram, and we'll discuss about this power supply circuit assembly AWR031 and about the power amp assembly boards for the left and for the right. These power boards, they have the indicative AWH023. So for the moment, let's focus on this power supply board. We'll discuss about this one. Like you see, somebody before was doing some maintenance, like I said in previous videos, and we'll see what it was replaced on this board. We'll see what we can do better, and if it will be necessary, we'll take some action on this one. For sure we'll do some cleaning, and we'll try to understand the circuitry. Yeah. Okay, so this is the board, which is this one here, and on this board we'll have two full wave bridge rectifiers each of them made by 4 diodes. After that we'll have this bridge rectifier, which is connected on the pin 2 and 4 on AC, which is coming from the secondary output of this transformer. So red, red and white. We'll have here red, red and white. It's also going on the ground, on the chassis. So white, white. After that we'll have the bridge rectifier, and from the bridge rectifier we'll have the outputs 1 and 3 points, and between both of them we'll have a resistor, discharging resistor for the capacitors. Yeah. And also this resistor, it will create a load on the full wave bridge rectifier. After this resistor we'll have the main power capacitors. Okay, so like I said, we have 2 and 4, which is going the alternating voltage inside the board on this section, and 1 and 3 it's going out, yeah, for DC. Here we'll have the board, we'll have the schematic, and after that we'll have the printed circuit board, and you see the view is from foil side. So that means this one here should be this one, and it's also stated here 1 and 2. So like I said, 1 and 2 will have AC voltage, and on 2 and 4 we'll have the AC, and after that on 1 and 3 we have the DC, according with the schematic. Yeah. Okay, so this is how it's going. We'll have the section here, we'll have the resistor for diodes, which they will create a full wave bridge rectifier. After that, if we'll go on the upper section, of this board we will have the pins 5 and 8 according with this diagram, and after that, which is AC, we have also 2 fuses, so we will find 2 fuses here, and after that we will have again a full wave bridge rectifier made by 4 diodes, and after that we will have 2 capacitors between minus, chassis, ground and the plus, and the DC voltage is going between the pins 7 and 9 and 6 and 9. Yeah, so according with this schematic we will have also here, and it's stated much more clear. So 5 and 8, you see we will have the AC voltage is coming here, full wave bridge rectifier, and for each diode we will have 0.01 capacitor, filtering capacitor, and after that we will have these 2 capacitors here, electrolytic capacitors for smoothing the DC. And on the board you see here full wave bridge rectifier made by these 4 diodes, 4 capacitors, film capacitors, and or ceramic capacitors. According with the schematic, before it was here some ceramic capacitors. Now the technician before installed the film capacitors, and these 2 fuses. Okay, according with my list, which is here, I create here a legend, like you know already. Capacitors, it's this magenta, green transistors, blue diodes, and yellow it's potentiometers and resistors. So this will be the parts which will replace. Here you will see parts list, yeah. So we have capacitors C5 and C6, 470 microfarads, 63 volts. According with my experience, I will recommend to replace them with axial capacitors, 470 microfarads and 100 volts. And for here, for the diodes, you will see we have 8 diodes, and some of them are stated for 2 amps, some of them are stated for 1 amp. So I will suggest you to replace this for 1 amp with ultra fast 4007 1 amp, and for these 2 amps I will recommend you to with 1N 5404, which are stated for 3 amps to replace. Yeah, and for this resistor which is there, R1, it's metal oxide, 10 kilo 2 watts. I recommend you to put 10 kilo 3 watts. Yeah, you can make the calculation, you will see the dissipation, how much it is. So this is with this schematic. Yeah, so you see everything is stated. You can make a print screen of your computer, and you will have very clear diagram, and you can save them and you can play with them in case if you restore a Pioneer SA 9100 resistor and also diodes. Yeah, so you have everything here. This is the way how I'm doing, you know already. Okay, so now what we will do, we will try to take out the board. It's also on each side we will have a holder, screws. We will lift easy the board. We will try to put here on this side, and after that we will play with the transformer around, and we will check all the parts how they look on the board, if we'll leave how they are, and maybe we can do some soldering, I don't know. Let's take out. You have 2 screws, one on each side, so you see one is here. We'll take out, and second one it's here, so we'll take also this one out. I want to cut this cable tie which is keeping connected the wires, because I don't like it. We'll replace later on. Okay, discard this one. So you see now the board, this board, it's floating, and we'll take out the screws, and you'll see are 4 screws more, 1, 2, 3, 4, which they are keeping in the position the board on this holders. Yeah, okay, so let's take also this out, and after that we will try to lift the board and to understand the parts which are here used, replaced by previous technician. Yeah, okay, so let's take this one, I see some cables here. Usually they are fixed by wire wrapping method. Yeah, see, wire up, wire up, wire up, wire up, wire up. So these are okay because are hard wires, but this one core wire, but these which are with more wires inside are soldered, and it's normal. So this one is correct here. So it looks like nobody was playing on these wires. So let's see if we'll be able to lift. If it's not possible, I recommend you to slack also the other board, which is on the front. I don't know if you see what I'm doing here. So I'm trying to slack the board which is on the front, yeah, to create enough room for this board. You see, it's like a surgery here, huh? Okay, so now you can move this board a little bit like that, and now we can turn this one like that off. I don't like how you like how he soldered it here. You like this? What do you think? Looks okay? I can leave like that? No, I can't. So I have to resolder everything here. But let's twist. Let's twist in the same way to not break the wires. You see, so the parts looks okay. So let's take out also the screws. Let's change the angle of camera a little bit. Okay, so one more here. Okay, so let's put out the fuses. So what I recommend for the fuse holders, you have just to clean a little bit inside. You can take a brush, and after that squeeze a little bit these two terminals to make stronger contact on the fuse. Yeah. Okay, so according with the drawing, what is written here? The fuses are stated for 1 amp, you see? Okay, so let's check our fuses. Oops, if they are 1 amp. This one is 1 amp, it's written here. Second one, it's 1 amp, also is stated here. Yeah. Okay, so let's see the parts. What I said. I said it will be okay if we replace these main capacitors with 170 microfarads, 470 microfarads, and 63 volts. Yeah. Okay, so these capacitors here are 63 volts and 1000 microfarads. It's okay. We can leave it. We can leave them like that. There's no any problem. So we can considering they are okay. Here, these red caps are the capacitors which are for filtering the bypassing the diodes on the full bridge rectifiers. Yeah, so we have two full bridge rectifiers, which they have in the structure 4 diodes. Each diodes have like a bypass these red caps, which are 0.01, 630 microfarads MKP from Weimar, which is really good. This resistor which is here is 10K, 3 watts. According with the manual, they said 10 kilo ohms and 2 watts. So it's exactly like I said, better to increase a little bit the rating. So what I'll do on this board, I will make some cleaning with some isopropylic alcohol. After that I will fix the soldering points, and we will clean. After we will finish with the board, we will clean the chassis here, and we will lift a little bit the transformer to be able to clean the support of the transformer. So I put some rags around here to not make mess. I will take some isopropylic alcohol. I am spreading around, and with the brush I am cleaning the flux in excess. Yeah? So this is how I'm doing. You see here are some scratches, and I'm trying to clean how much I can this flux, and after that I will check all the soldering points, because some of them I don't like. Here, if you see, if you are looking here, it's some space between the globe of the soldering and the base. So this one I have to reflow it. Yeah. So I will use the vacuum pump. I will remove this flux which is here, and after that I will create new soldering point. Yeah. So this is the way how you can do it, and after that I will check all the connectors, wire connectors here down, to be sure everything it's in good shape, and I will be sure all the contacts are perfect. So this is the way how I'm doing. If you have other option, you can share it with us. What you think? It's okay like that? To proceed like that? From my point of view, yeah, it's okay. If you have other opinion, don't hesitate to leave down. Now the board looks like that. You see another soldering joints. Also all the pins down are soldered. I started to clean also on the chassis there. Cables are cleaned. I want to show you how it looks on the other side. Also I started to clean here. I will focus on cleaning now the chassis, and after that we will try to lift the transformer. So you see, it looks very nice. I will fix also the fuses on position. After that we can put the board back. So I reflow all the soldering points. For trafo nuts you will need 8mm socket, and you can remove the nuts. After you touch the last one, you have to secure with your hand the trafo on the other side, because it will jump. It will stay on the wires, yeah. So this is the third nut. Also you'll put down, and the last one. So like I said, one hand on the other side. You will take out the nut, and you can see now the trafo, it's floating, yeah, and it will stay on these wires. So now you can see I just lift it, and I will let like that. So now I will have enough room to throw a rag down here with isopropylic alcohol, and I can clean everything without any problem. Yeah, I will clean everything, and after that I will fix back after I will finish. So in this way I will be sure everything around trafo it will be cleaned. You see here it's a lot of dust and lint, yeah. Everything it will be shiny also here, you see. Look. So everything should be clean. Okay, so I will do this out of camera because it's not so nice to see me how I'm removing the dust. And I will start the camera after I will do this, and we will start to fix back the trafo. You see now it's shiny, everything, also trafo, and also the space below. Everything it's reflecting the light, so it's like it should be. Okay, so now I will fix the trafo back, and we will put together this board on position. So the board is on position now. I just finished to tighten the screws. Trafo is also fixed. Like I said, around trafo and around this power supply board, the dust is cleaned. The chassis looks very nice. I secured the cables with a cable tie here, like you see. And after that we have to arrange the cable on the other side. Now I will continue with cleaning on this side. I will clean the chassis around here, after that around here, and after we are finished with cleaning on both sides, we will start cleaning on the lower part, but also on this sector here. And when we will finish there, we will start with the boards one by one to overhaul. So I will do the cleaning around here, like I said, this part and this part, and after that we will start the camera back when I will start to clean the cabling and everything what is on the other side. Both sides on top are cleaned. You see, they looks very nice. We'll continue the cleaning now below, like I said, on this sector here. We'll clean the cables and also the cables on that side. Trafo, we'll check the cables for trafo, and we'll make this cleaning together. We are now upside down, so we'll start with these cables here. I want to be sure all of them they are clean, because the dust it's passing these holes, and it's normal to be like that because these holes are made for air circulation, for cooling down the heatsinks of power transistors. So this edge also here should be closed, cleaned. So now we will take the cables one by one on the rack and you will clean. From first to last. And now for sure everything it looks okay. Everything what belongs to the back side you saw we clean on the previous videos. We will clean also these cables. Now I will put this ones on position and I will continue with the rest. So this is how I'm doing. If you want good results, you have to put some energy here. And the result, it will be very nice. Also this section is cleaned. The lower part, cables, all these parts here. I was not cleaning here below this board because for this one we have to do some maintenance, but on another video. I clean around transformer, I check all the cables are soldered well. Also here, you remember on some amplifiers we found the cables not in good shape. So for this one it looks okay. I remove also these cables here from the holders. I clean all of them. Now you see, there's no any dust. Everything it's perfect. So let's continue with the diagrams for the amplifier boards, power amplifier boards. We'll discuss about the parts, diagrams, circuits. Let's go on. So here is the power amplifier board. This is for the left channel. Like you see here on the side we have the emitter resistors, belongs to the power transistors. Here are the drivers. We have to take out to replace the grease. Here behind are 3 resistors, limiting resistors, we will replace also them. Here are some capacitors, which we will replace. Some of them for the audio source input, we replace with fin capacitors. These capacitors we will take out also, and they will be replaced. These multi-turn pots, they will be replaced with Burns pots. Blue ones, you know I like that one. And these 2 transistors, 2SC1451, they are prone to static noise. So we will take also this out and we will replace with KSC 3503. So let's see for a moment the diagram, the block diagram. You'll see here AWH023. You'll see how it's connected. We'll have also here down the connection of the boards, because are two, yeah, they are same. And here we have the power amplifier board. It's much more visible. Okay, so power amplifier assembly AWH023B. Okay, so like I said, capacitors magenta, transistors green, diodes blue, resistors or potentiometers or trimmers yellow. So this is the diagram. You can see here how it looks. Here are the power transistors. They will remain on the place because they are in good shape. Like I said about the drivers, they will stay also on position, but we have to take out to clean the old grease and to install new grease. Pay attention to this STV4A, the bias compensation diode, because the terminals are very sensitive, so avoid to play too much with them, to not broke them, because you know what is the idea? They will not broke on the board, they will broke exactly on the edge of the casing of the diode. Usually they are coming weak or weaker here on the where the terminal is making the joint with the body of the diode. Yeah. So here, like I said, is the output section. We discussed about 3 resistors on the board, and I told you we'll replace. So here we have minus 45 volts, plus 45 volts. So that means here we'll have a voltage. Before entering on the collectors of the drivers, we will have 2 resistors, 2 voltage drop resistors, 10 ohms, 1 watt, 10 ohms, 1 watt. We'll replace these 2 resistors with 10 ohms, 2 watts. Yeah, these resistors from Mauser. Yeah, and also it's one here. You remember what is doing this circuit? Yes, I know you remember. Here is the output signal which is passing that 2 big resistors, emitter resistors of the power transistors. The signal is going to the protection relay, and after that is going on the speaker. Here is the Zobel circuit, and he is taking care about oscillation. Okay, so let's continue. So these 3 resistors will replace. I show you the model for them. After that, this kind of construction, he is using 2 adjustable trimmers. These trimmers, what they are doing, this one which is here, he will adjust the DC offset, so it will adjust the differential input transistor pair. So this one, it will play on this section here, and we will adjust the DC offset on the speaker terminal. And the other one, he will adjust the bias, you see. So we'll have the trimmer diode. After that we have this compensation diode, and here we will have a closed circuit. And after that the signal is going on the drivers and on the power transistors. So with this one we will adjust the idling current. If you know what is the idling current, I create already a video how to adjust it. I will attach a link here on the top, but you will see also later on next videos how we'll adjust the DC offset and the idling current for this unit. So these potentiometers, the streamers, they will be replaced with burns. You know, I like this blue. I know they are new, all the parts are new, and we'll replace with this multi-term burns, both of them. Why we are replacing them with multi-turns? Because you'll have normally original potentiometers which are here, not this one which we found on the board. The original ones, they have less than 1 turn. So when you adjust, the setting is not so precise. If you are installing multi-turn, he is using 12 turns between 0 ohms until the, I don't know, 100 ohms or 330 ohms, how much is here. So you will have to turn 12 times. Okay, so this is about potentiometers. We have also some diodes here, which I want to replace them. For these replacements, we'll use this 1N. I will show in a moment. We'll replace this 1S2473 diodes. We'll replace with 1N4148. Yeah. So this will replace 1N4148. It will go instead of 1S2473. I will replace these diodes. Why am I replacing this? Because I want to be sure they are okay, and they will be okay for the next years. So it's up to you. If you want to leave on position, you can leave. It's not any problem. But according with my previous restoration, usually I'm replacing this. After that, we have the capacitors. Like I said, we have capacitor 1 and capacitor 2. This one is 0.22 microfarads and 0.47 microfarads. Also before, the original capacitors, they were electrolytics here. Now I will replace with film. 0.22, 63 from Weimar, 0.47 microfarads also from Weimar, and 63 volts also. Yeah. So these two capacitors, they will be replaced with this, and remains 3 cups more, and we will have like that 33. You see, so 1, 2, 3, 3 more, and we'll have 33 microfarads 16 volts, 33 microfarads 16 volts, and 170 microfarads and 6 volts. So for these 3 caps, I will use the audio grade caps, audio KA, yeah, also from Nichicon. I like this series, so I will replace with them here. So more or less this is about the schematic. So I will keep this one like that. You can make a print screen if you want, and you will have it. After that, we will have here the printed circuit board, but you will have the view from the foil side. So that means you have the view from the lower part of the board. Yeah. And here I make also the position for the parts. You see, this is what is yellow are resistors and multi-transports, trim pots. Diodes, all of them with blue, transistors, and the capacitors. I will explain you in a moment why I made with green this all transistors. And the capacitors, yeah? So this is the position on the board. So let's come back on the diagram, and we will discuss about the transistors. Here we have the differential pair, yeah? So we have 2 transistors which are matched, yeah? They are coming together, so it's better to have both of them with the same amplification. What they will do, these 2 transistors? So from one side of this transistor we will have the signal or controlling signal for the output of speaker, yeah. You will see it's the same line, yeah. So it's acting like a feedback, yeah. And on the other side we have the signal which is going also in the same way, yeah. So this one, he is trying to make a balance. When you adjust this trim pot, also you are creating a balance, and this balance we are calling DC offset. If you don't have this trim pot here, you have to adjust and to pair very good these 2 transistors to have here closer to 0 millivolts. If these 2 they are not properly matched, and if you don't have this multi-trim pot here you'll have a different value from 0, plus or minus, I don't know, couple of millivolts or hundreds of millivolts. So the story is because of this. After that we have the other transistors which are green, yeah. We have drivers and power transistors. So these 2 transistors you replace only if it's necessary. Here these 2 transistors, they are 2 SA774. This with metal casing, but not these cans behind, yeah. So our 2 transistors, metal transistors, we will not replace them. After that we will have the transistor Q3, Q5, Q6. Q5 is 2SA628, Q3 and Q4 are 2SC869. All these 3 transistors, they are not prone to create noise. You replace all these 5 transistors only if you have noise or if you have problems. On this amplifier, these transistors, they are not making problems. They are not known with problems, these transistors. So I will not replace them. But I put here because usually on amplifiers, you can have troubles also with these transistors. So this is the reason why I made them green, but we will not replace on this one. What we will replace on this one, we will replace these 2 metal can transistors. And these 2 metal can transistors, you see, are behind of these driver transistors. Yeah, we have Q6 and Q7. Q6, both of them are the same, are NPN transistors. So both of them, they are 2SC1451. They are prone to create noise. Yeah, you can find this on Pioneer SA 9500, also on S6 950, 850, on Pioneer SA 9900. So all these devices which I specified now, they have a lot of these transistors. They have also on other boards. Yeah, so this I suggest you to replace. And what we will do for them, instead of this, we'll put KSC 3503. Yeah, so I will show you in a moment. So this is what I will do on the power stages. On both of them, they will be same. So make a print screen also for the foil side, and that's that. You see, I made on the top some marks for idling current, how to deal with them. And the trim pot which is closer to the corner is DC offset. So that means here is this DC offset, and this one which is closer to the driver transistors, it's idling current or idle trim pot. Okay, let's see also the parts. So you see capacitors. So you can make a print screen now. So part list of power amplifier amps. Like you see, I put multiply with 2 here because we have 2 boards, and the list is only for 1 board. C1, C2, C3, C6, C7, C12. You see, these are electrolytics. So 0.2225. This one we will replace with VIMA. Second one with VIMA. Third one with UKA or UKT audio caps. And for the others, same, 3350 volts, 470 microfarads and 16 volts. So higher value. About the resistors, you can see on this one, you can make a print screen now. We'll have resistor R32 and R24, like I said, 10 ohms, 1 watt. They will be replaced with 10 ohms, 2 watts. Okay, and on the other side remains one resistor for 1 board. Resistor R31, 10 ohms, 1 watt. It will be replaced with 10 ohms, 2 watts. After that, we'll discuss about transistors and diodes or semiconductors, also multiply with 2. Like I said, you see, I put here M. That means it's matched, so you have to match it. Yeah. So for Q1 and Q2, you can replace with KSA 992. Q3 and Q4 also KAC 1845. They are these 2 transistors. They are very nice, and you can find them. Q5 KSA 992, and Q7, Q6 and Q7. These 2 transistors which we replace, they will be with KSC 3503. So, like one more time about these transistors from Q1 to Q5. Replace them only if you have problems. If not, don't touch them. Okay, if you replace with this, you will have highly chances to reduce a little bit the noise, continuously noise. But to keep this amplifier more originally, because these transistors, they are not making any noise, leave it like they are. About diodes, you will see each board have 5 diodes. I will replace them with 1 and 4148. After that, about coils, we will not replace nothing. About the trim pots, we will have here VR1, VR2, 330 ohms, 100 ohms. And we will replace them with Borns, 3296P, 1501 LF. Yeah, and here are the codes. You can use these codes to order from the Mauser. And for the others, it's nothing. So this is the board this is the explanation for this board. This is the way how I'm doing this. It's just my way. You can do how you want. About this toucan transistor, I said we replace with this KSC. Yeah, KSC 3503. About the resistors, we'll replace with these resistors from Panasonic, if I could remember, 10 ohms, 2 watts. Yeah. Okay. Diodes are diodes from VSHI or ON-Semi. Okay, capacitors, these capacitors are from Weimar 0.47 and 0.22 for audio input. After that, 470 microfarads and 16 volts. It will be this cap from Nichicon audio grade. Yeah. After that, we will have for each board 2 caps, 33 microfarads and 50 volts, also audio grade. And what remains? Remains also the trim pods, one for this board and second one also for this board, because they are different. Yeah. How we'll adjust these trim pods before you'll put on position? So usually I'm doing like that. If the equipment is working, I will set the DC offset on the middle of 0 millivolts, and I will reduce the idling current closer to minimum value, 1-2 millivolts. After that, I will start the overhauling. I will take out the potentiometers, the trim pods, up to you, and I will measure between middle point and the point which is not connected with the middle point. Yeah, because depends of construction of the boards. You can have the trim pod. Normally the trim pod, it's connected like that. Yeah, and you'll have here the wiper. Yeah, and the wiper it's playing around. You can have in the circuit, you can have the possibility to connect this one. One connection is you'll have here a circuit, here it's another circuit, and here it's another circuit. So that means from this point to this point you will have entire value 330 ohms, like example. Yeah, so the wiper, it will play between this point and this point, so it will start to play it from one side to another one. Yeah, so like example, this one it's like a voltage divider. Yeah, so if you'll put this wiper on the middle, so that means between this point and this point you will have how much? You will have 165 ohms, and here 165 ohms. So that means here if you have 10 volts, that means on the middle you have 10 volts. You got it. Okay, or you can have another diagram, which is the trim pot, it's similar. Yeah, also the wiper here. And what's going on? You can have the wiper connected with this point here. You see? So now it's another story. If we'll measure the resistance here, and if the pointer it's on the middle, so between this point and this point you will not read 330 ohms. You agree with me? Because the current, it will pass the lower resistance. So if this one is on the middle here, from this point to this point the resistance is higher than this one. So that means the current path, it will be like that. So that means between this point and this point you will have 165 ohms. Yeah, so when you are putting on position the trim pods, usually how I'm doing, let's focus. Usually how I'm doing, first of all I'm checking the board to see what is the connection of the trim pod on position, and I will see, and after that I will have a rule. From the multimeter I have two connectors. Yeah, one I will stick on the middle point. Okay, first of all I have to take out to desolder the part. I will take the trim pot out, and after that from the wiper I will connect a wire on the multimeter, and on another one, yeah, like example, if it's for this section here, I will take this one, because if I will measure between this wiper and this one, when it's out of the circuit, on the circuit here it's a short circuit, yeah, because you will have this loop. When you will take out this one, it will disappear. So if the value of the trim pot, and usually is like that, it's very difficult to find a trim pot now on these days to have exactly same value like that one which you take out. Trust me, even if it's written on both of them 330, it's not. It's totally different. They are not similar. So trust this. So if you'll measure here, you have highly chances to make wrong, yeah, you'll set a wrong value. So I suggest you to, for this installation, to use the one lead of the multimeter to put on the wiper, and the second one to put on this one here, yeah, and you will measure. And for this one which is connected on this position, you can put how you want, on each position which you want, but one should be on the wiper, but the second one can be here or can be here. You will measure, yeah. So like example, you take a trim pot out and you will measure between this one and this one, you will measure 55 ohms, yeah. Okay, you will take new trim pot, you will put the leads of the voltmeter, of the multimeter, in the same position, and you will adjust 55 ohms, yeah. So keep in mind this, follow these steps. Okay, a lot of talking. Okay, so here are the parts. These are the parts which belongs to one card, yeah. So now it's clear with this, yeah. So usually the wiper is on the middle, and the ends of the resistor are on the sides. If you are looking closer, you can see on the bottom, you will see the resistor, entire resistor, and also the wiper. Wiper is 2. Beginning of the resistor is 1, and the end of resistor is 3. So it's exactly like I draw for you, yeah, like I made that drawing for you. Okay, so now I will start to replace the parts on the boards. First I have to desolder. I will run the camera for each step. I will not run continuously, but I will run for each step to see how I'm doing with this, yeah. Okay, so let's see also how it looks, the board, after the previous technician he was playing with. Okay, so here is the board. So try to keep also in your mind the position of the parts, how they are, yeah. So you see, especially these two drivers, you have to see exactly what is written on them, because I think both of them, they are black. One should be NPN, one should be PNP, yeah. And you have to put back in the same position. Usually one is blue, one is black, but when both of them, they are black, you have to be sure you will not mix them, yeah. Here is the board, how it looks on the foil side. You see here some, yeah, let's see. So I'm looking for the soldering, how the previous technician make the soldering points. So you see here, it's a lot of flux, but we'll clean. Like you see, the driver transistors, they are never been drawn out, so it will be first time. About the compensation diode, we remember on the diagram was written STV4. You see, STV4. So pay attention with them. Pay attention, high attention with them. So now I will take the desoldering station. I will desolder all the parts, all the terminals for the parts, and after that I will start to take one by one, and I will replace with new ones. And we will do in the same time the cleaning of the board on both sides. And I will show you how I will deal with tremors. Now with the desoldering station, you have to check the parts, where they are. Just put the desoldering station, melt this soldering compound, and create the vacuum and remove the soldering material. Be careful to not lift up the pads, because it's important to not do this for this stage of the device, especially because somebody works before here. So pay attention to the trimmers to not remove, to not lose on the other side, because like I said, you have to measure them, and I will show you exactly how they are connected. Here are the driver transistors. Also, you see how I'm doing. One time I'm desoldering, and with the finger on the back, I'm moving the part. Yeah. Why I'm moving the part? To avoid the soldering to form between the soldering soldering pad, sorry, and the terminal. Yeah. So if I'm moving the part, I will be sure it will not remain connected somehow. So this is the way how I'm doing this. Okay, so I'll do the rest of on the back of the camera, and I will show you how I will deal with these trimmers, how I will measure and how I will deal with them. Okay, so now the parts are desoldered, like you see here. So let's discuss about the trimmers, and after that we'll discuss about transistors, the way how I'm dealing with them. Yeah. Okay, so let's take out this trimmer. Okay, so this trimmer is out, was like that. Yeah. So let's check the terminals here. So first terminal, second terminal, like you see, and the third terminal. Like you see here, the third terminal is not connected. So this one have connection with the circuitry. This one is not connected with no any part, so it's in air. And this one is connected with the circuit. So here is the wiper, and here is the one end of the resistance. Yeah? So what is important for us to measure between this point, this wiper, and this one? Yeah. So let's see how it looks. So this is the trim pot. So here is the wiper, and here is the end of the resistor. Yeah. So this pin and this pin, they were connected in the circuit. This one was in air. Why? Because we have to check on the diagram. So this one is the idling current. I see I put in opposite way. So you see, where is it? Here. So it's one end connected, and the wiper is connected with this end here. Yeah, so you see this trim pod have only two connections points. Yeah, so it's clear why it's like that, because you saw also on the printed circuit board. So now we have to check between wiper, to check the resistance between wiper and this end, and after that we'll adjust this one, which it will be instead of old one, between wiper and this end. Yeah. So I will do this with multimeter. So one more time, you have to be aware of the connection on the board, because if you adjust on opposite way, you will have not correct adjustment. Yeah. And of course, when you will start your amplifier, you have to start it controlled by a variac and also by a dim bulb tester, let's say. So let's measure between this point here and this point of the wiper, and the reading, it will be 15.13 ohms. Because this one is new and it's 100 ohms, now the value, it will be on 50 ohms, because usually they are adjusted from factory on the have value. Yeah. So let's adjust for 15. So now with the screwdriver, you will adjust and you will read on the screen of your multimeter to see the value. So now we are on the 15, yeah? 15.05. let's measure one more time to be sure we don't make mistakes. And it's 15. It's not stabilizing because these terminals are a little bit dirty. So it's 50, 50, yeah? Okay. So we'll adjust this one for 15, 50. Okay, so 15, 50. So this is the way how I'm doing, yeah? So you will put on the board in the same position like this one. I will do same for the other one. And after that I will show you how I'm dealing with the transistors. So about transistors, the story is a little bit different. How I'm doing every time. So I'm checking the position of the transistor on the board. On the transistors and the boards which they have seal screen, I will check the seal screen and I am comparing with the service manual. But sometimes they are different. You see how they look, these soldering joints here? I don't like. So let's come back to the transistor. So I'm looking at the transistor, and like I said, the seal screens, they are not all the time like on the manual. So, but you know that device was working. So that means the parts, the components inside the boards, they were fixed correctly, yeah? So that means we'll trust the position of the parts on the boards. So now what I will do, I will check also the seal screen on the board. Yeah. So you see, now it's visible the collector of the transistor on the seal screen and the base. So we'll keep in head collector, base, and on the other side we have the emitter, yeah? So let's see. So collector, base, and emitter. The first one is the emitter, yeah? Okay, so now I will take out, I will keep in mind the position of the terminals. So collector, base, emitter. I will put like that, and I will keep in mind collector, base, emitter, and I will show you what I will do. So we will take the transistor, and we will use a tester to see exactly if it's like we said, collector, base, emitter, yeah? So I will fix the transistor here, and I will start. So collector, base, emitter, and you will see the amplification factor, it's the beta is 91, and it's NPN. So collector, base, emitter. That means the seal screen on the board is correct, so I can follow that seal screen on the board. So this transistor, it's 2SC1451. I told you it's a problem transistor, it's giving problems. So you have to be aware of this. You see it have also this cooling aluminum piece of metal, yeah? It's for cooling. And we will use, for this application, we will use this one, KSC 3503. It's a good transistor. And let's see also the terminals for this one. So this is the transistor which it will be on the place of this one, and the terminal position is emitter, collector, base. So this one it will be instead of this one. So this is about transistors. This is the way how I'm doing with them. So you see now we have these diodes, and we have to bend the terminals. You have more options to bend, yeah? You can take a plier or a pair of tweezers, and you can grab like that, and you can bend, yeah? And you'll do a proper job, of course. But if you want to do faster this, I recommend you to buy this tool. You can find on Mauser or DigiKey. Let's change a little bit the angle of the camera because I think we are too close. Now it should be better, yeah? So you can find this tool on Mauser or DigiKey, and you see you have more more options to bend, yeah. And you can take this, if you like example, if your terminals are bended after you remove the parts, you can take this unit and you can put closer to the board and you will measure the distance between holes. But if you have the parts here, you can put, and you can see this is the position how they should be. So you will choose first dimension and you will take the new part, you will put center here, and you can bend the terminals without any problem, yeah. And you can do same for all of them like that. Very easy, yeah. And after that you can put the components back on the board. And I will do same with the resistors. And this unit is okay only for 2 terminals parts. And this is the way how I'm dealing with this. I hope it's useful for you, because on the beginning I didn't know about this tool, but I found it on suggestions. I was looking on the Mauser, I was ordering parts, and this one was on the bottom of the page like a suggestion, and I said why not to have on stock. So here are the driver transistors. The plan is to take out the screws and to see how it looks, the grease, thermal grease paste. On that days they use some glue paste. It's not the paste which you know from my previous restore. You see it's shiny. You see? It's shiny, it's something sticky. It's like a, I don't know how to call, glue. It's like a glue, bison glue or that kind. You see? You have to clean very well, but not with screwdriver because I'm afraid to not scratch. And also the terminals, I will make them sharp again and straight to be easy to fix back on the board. So I'll do this. Okay, so now the transistors are cleaned. Heatsinks also. I will add some thermal paste on them. First one and second one. And after that you can fix back on heatsink. Tight the screw and fix on position. So now I'm 100% sure all the air gaps, they will be filled with this thermal paste, because this is the reason why we are putting thermal paste, yeah, to fill the air gaps between the part, component and the heatsink. So now I will put the transistors back and I will tight the screws. Be careful to not make mess here with this grease, because to be honest I don't like to put the fingerprints on all components. I don't like when I see audio equipment with fingerprints with this thermal paste. Unbelievable. I don't know how some technicians they can do like that, but this is the way how they are doing, yeah. So now I will put the screws and I will tighten the transistors on heatsinks, and I will put the parts inside the board. So I just finished the cleaning. I used isopropylic alcohol with a brush. I just clean all the flux which remains, and after that, after the alcohol was evaporated, I used the brush, and on the brittle of the brush I used this CRC226 to give this shiny layer and protector, and this layer it will disappear after a couple of weeks, and it looks like that. Let's see how it looks on the other side where you have the parts connected. So here we have the parts. You see everything is shiny now. All the parts which I replaced, you have seen already, are in proper position. Big transistor, blue capacitors and red capacitors, blue trimmers, new thermal paste for transistors, driver transistors. I clean also the terminals for them. And this one is ready to be stick with heatsink and power transistors. Now I will start to do this board. It will be similar with the other one. You see what I mean about the flux. I don't like to leave the flux like that. Yeah, on the connections on the soldering pads. So I will do same with this one. I will clean all the components and I will replace the components like on the previous board. So I just finished cleaning the heatsinks and the supports. On the heatsinks we'll fix the transistors, power transistors. I just clean also the power transistors. I remove how much I was able this glue. I will install new mica pads because the original ones they had this glue and I prefer to use new ones to avoid these deposits. About the thermal paste, I will use this one type 120 silicone. They are made in it's made in USA. It's really good quality. So I will show you all the steps how to fix the transistors on heatsinks and how to fix the heatsinks on the chassis. And I will show you also my method how to apply this thermal joint compound. So let's start this. So I fixed the board on position. We have to fix 4 screws to keep the board with the heatsink. And now we have 4 screws to fix entire pair with the chassis. So we need 4 screws to fix this heatsink support. And after that we will be able to fix the compensation diode. You see is this one which is lifted here, and we will fix also the transistors and micas, and we'll continue with the other channel after that. So I will fix these screws out of camera and I will start and we will put the grease. So before you start, first of all you have to arrange the sockets, the transistor sockets exactly on the holes in the heatsink, yeah? Okay, so you see this one is fixed, this one is not. You see it's flying around here. So the pair of tweezers you can arrange perfect. You see? So both of them they are on position. So now we can focus to add thermal paste on transistors, and after that a layer on the mica pads, and we can install them on sockets. So let's focus on this. So how I'm doing, my method is like that. You will take a toothpick, you will grab a knife, you will cut this sharp end. After that you will take the grease like that. You will take the transistor and you will spread this grease evenly on the base. The idea is to fill all the gaps with grease to reduce the air pillows which are here. Yeah? This is the idea of using this grease. But in the same time don't put so much, because if you put too much it will be spread around the transistor. So it's not necessary to put so much quantity. You see, so this one which I put here, it's more than enough. You see how it looks. Now you will take a mica pad. Be careful how you will put, because it's only one position available for this mica. I'm pressing like that. and you can see how was spread. And now you have to put grease also on this mica pad, also spread evenly everywhere. I like to play with this grease. So this is my method. I saw also other methods on the internet with some brushes, but after that you have to clean the brush. You have highly chances to have dust on the brush and lint, so I prefer to do in this way, because after that I will dispose this stick. And now you will turn the transistor. You will see exactly what is written on the transistor, and you'll have to arrange on his position on the heatsink. Yeah, it's very important. Don't mix between. Okay, on this unit are only 2 transistors, but when you have 4, 6, 8 transistors, you have to be aware of the position. Yeah. Also, the position it's only one. You can put only one position, because you see between this hole here and the pins, the terminals, it's the distance is bigger comparing it with the distance from the terminals to this hole. Yeah, so you have to arrange proper on here. So how I'm doing with this wood stick, I'm just pressing behind the connector. So you see I'm pressing to be sure it's not going back when I will put the transistor here. So you have to put on position. So now the transistor is on position, you see. Now you will put the screws up and down. You have 2 screws for these TO3 transistors. You will take a screwdriver and you will tighten the screws. Usually I'm tightening 3 times these screws. First time I'm just appropriate the screws like that, and after that I will tighten 2 times more to be sure the grease is spread all around. And I will show you exactly how it's visible here. You see how it looks. It's perfect. So I will do same for the rest of transistors, and after that we'll focus on the compensating diodes. We'll put also grease for them, and we'll tighten them also for better temperature transfer. So you see both transistors, they look like that. It looks different than it was before, because before it was used different type of liquid used between the transistors and the heatsinks. Now you see it's white grease, and you can find this grease on Mauser without any problem. Now I will put a globe of thermal paste on the biasing compensation diode, and this one, it will stay something like that here. Okay, so I will put and here is the device for fixing. Yeah, so I will put here on this part, this side, I will put some grease, and after that I will tighten this biasing diode. I will show you in a moment. So I will lift the diode. I will take this terminal. I will take some thermal paste, same thermal paste, and I will put like that. See, now I will have a proper transfer medium. Yeah. After that I will secure with this metal part, and it will be perfect. So they looks beautiful. Also the left channel is ready. You see, also the compensation diode is fixed with thermal paste. The boards looks beautiful, they are cleaned. Trafo also it's cleaned. This power supply, first power supply board, it's also okay. We clean also here on the back. So this sector here it's done. What remains now? I want to start cleaning a little bit the capacitors. The capacitance of them, it's okay. They are in specs. And I will clean also the frames, these rings supports. On one of them I see the screw it's bent, so I have to replace that screw. I replace both of them. I'll fix on position, I will tight, and you can considering this section here it's ready. Also the capacitors are on position, like you see. All the screws they are fixed, supports are fixed. That two screws which they are keeping the rings, which are creating the pressure on the rings, I just replaced them because the original ones they were bended. So I replaced them. Trafo looks okay, the other channel it's okay, so I will show you how it looks on the other side where we have the connections for the capacitors. So here are the connectors. The wires are connected, they are tight. I just clean all the cables here, cablings. And on this video we'll start with this board. So I hope you enjoyed this video. I was trying all my best to record and also to work. And if you have some comments or suggestions, don't hesitate to leave down. I want to show you the parts which we take out from these two power amplification boards. So here are all the parts replaced on both power amplification boards. So as you are some of them. Some of them they've been replaced before, but you know, I like to use some film capacitors for some audio pad, and for power supply I like to use Nikon UPW or UHE, and for audio I like UKA or UKT. If you like this video, don't forget, like I said, thumb up, share with others, and stay tuned. This is the end of video number 3. Well, in this video we discuss about the power transformer, main capacitors, clean the chassis, and the power amplification boards, and all the steps to do this. So thank you guys, see you on the video number 4. All the best, cheers, see you.